Download this code from codegive.com, link in the description below. Understanding ByteArray overflow error 93, bytes above 127, 0x7f, in actionscript 3, as 3. The overflow error, 93 in actionscript 3, as 3, when working with ByteArray objects specifically arises when you're trying to write or manipulate a byte that's interpreted as a signed 8-bit integer and its value is outside the valid range for a signed byte, -128 to 127, 0x80 to 0x7f in hexadecimal. This error usually happens when you're expecting values to be treated as unsigned bytes, 0 to 255 or 0x00 to 0xff, but the methods you're using interpret the bytes as signed. Let's break down the concepts and explore the reasons, scenarios, and solutions with detailed explanations and code examples. 1. Fundamental concepts, signed versus unsigned bytes. Unsigned byte an unsigned byte can represent values from 0 to 255, 0x00 to 0xff. It uses all 8 bits to represent the magnitude of the value. Think of it as a positive integer or a representation of an absolute value. Signed byte A signed byte can represent values from -128 to 127, 0x80 to 0x7f. It uses the most significant bit, MSB, to represent the sign. If the MSB is 0, the number is positive, 0 to 127. If the MSB is 1, the number is negative, -1 to -128. Why this matters? ActionScript 3, by default, treats bytes read and written using certain ByteArray methods as signed. This means that if you try to write a value greater than 127 into a ByteArray using methods that enforce signed interpretation, you'll trigger the overflow error, 93. 2. The culprits, ByteArray methods and data types. The key methods in the ByteArray class that can lead to this error are primarily the signed read and write methods. Write byte, value int void writes a single signed byte, -128 to 127. If value is outside this range, you'll get the error. Read byte, int reads a single byte as a signed value, -128 to 127. If the underlying byte represents a value above 127, it will be interpreted as a negative number. Important note: other methods, such as write bytes, read bytes, or the write unsigned int, /read unsigned int, pairs, generally operate on larger data units, example multiple bytes, integers, or explicitly treat values as unsigned. They are less likely to trigger this error directly, unless the data you are feeding them is being manipulated incorrectly before being passed to the ByteArray methods. 3. Scenarios where the error occurs. Here are the typical scenarios that lead to the overflow error, 93. Writing a value 127 using write byte, This is the most direct and common cause. Reading a value 127 using read byte, when it's supposed to be unsigned If you're reading data from a file or network stream that contains unsigned bytes, 0 to 255, and you use read byte, the values 127 will be interpreted as negative numbers, -128 to -1. This is usually not an error in itself, as 3 is correctly interpreting what's in the byte array, but rather it's an indication you're reading signed when you should be reading unsigned. The error occurs when you then try to write it back. Incorrect data type conversions before writing If you have a value that's naturally larger than 127, example read from a user input field, calculated from other data, and you try to force it into a byte, using typecasting or some other technique, without handling the overflow, you might end up writing the incorrect value and causing problems down the line. 4. Code examples. Let's illustrate these scenarios with ActionScript 3 code. Explanation asterisk. Asterisk test write byte error, asterisk this function demonstrates the most straightforward case. We try to write the value 200 to the byte array using write byte. Since 200 is outside the range -128 to 127, the write byte method throws the overflow error, 93. The try catch block catches the exception and displays an informative message. Asterisk test read byte unsigned, asterisk this function simulates reading an unsigned byte and then attempting to write the signed interpretation back. This is crucial to understanding the error. 1. Store the byte asterisk we manually store what represents the byte 200 into the byte array. We have to store it as int, 200 to 256, because when you store a number in the range 128 to 255 directly, it will interpret it as the signed byte. So, the byte actually stored in the byte array is identical to what would be stored if we stored a value of -56. 2. Read as signed asterisk we then read this byte using read byte. The read byte method interprets the byte as a signed value. Because the underlying byte value represents -56 when read as signed, it returns -56. 3. Attempt to rewrite the signed value asterisk the important part, when you try to write -56 back with write byte, it works. This is because -56 is a valid signed byte. The reason this works is that the byte array.write byte, int, 200 to 256, operation originally stored the signed representation of 200. You cannot directly store 200, as the code will be interpreted as -56. To fix this, you have to use write unsigned byte. 5. Solutions: how to handle bytes 127 correctly. Here's a breakdown of the solutions depending on your specific scenario. Asterisk use write unsigned byte, value uint void when dealing with unsigned bytes asterisk this is the most direct and correct solution. If you know you're working with unsigned bytes, 0 to 255, use write unsigned byte, to write the data to the byte array. Asterisk use read unsigned byte, uint when reading unsigned bytes asterisk similar to above, read the data with this function if you know the bytes are unsigned. Asterisk masking to ensure values are in range, when absolutely necessary if you must use write byte, for some reason you have no access to the write unsigned byte method, you can use a bitwise AND operation to ensure that the value is within the valid range. This is generally not recommended unless absolutely necessary as it can be confusing and less efficient. Important asterisk this will effectively wrap around the value. In this example, 200 will be 200, but write byte will still treat it as signed, so will throw an error. This operation is much more helpful when you are using the value elsewhere, such as for color values. Asterisk handle the read byte, result correctly asterisk when using read byte, and you know the value should be unsigned, you can perform a conversion to get the unsigned equivalent. Alternatively, and perhaps slightly more readable in some cases, you can perform a check and adjust. Asterisk use larger data types asterisk if your values can exceed 255, consider using larger data types like int, 32-bit integer, or uint, 32-bit unsigned integer, along with the corresponding write int, write unsigned int, read int, and read unsigned int methods. 6. Best practices and avoiding future errors. Know your data. The most important thing is to understand whether the data you're working with is intended to be signed or unsigned. This information typically comes from the specification of the file format, network protocol, or data source you're using. Use the correct byte array methods. Choose the byte array methods that align with your data's interpretation, signed or unsigned. Prefer write unsigned byte, and read unsigned byte, when appropriate. Consistent interpretation. Be consistent in how you interpret the bytes. If you read a byte as unsigned, treat it as unsigned throughout your code. Debugging. When you encounter overflow error, 93, carefully examine the value you're trying to write to the byte array and verify that it's within the valid signed byte range, -128 to 127. Use trace statements to inspect the values at different stages of your code. Comments. Add comments to your code to clearly indicate whether you're working with signed or unsigned bytes and the rationale behind your choices. This makes your code easier to understand and maintain. Complete example illustrating the correct approach. Here's a complete example that demonstrates how to correctly read and write unsigned bytes using write unsigned byte, and read unsigned byte. Summary. The overflow error, 93 in ActionScript 3's ByteArray class is a consequence of the distinction between signed and unsigned byte representations. By understanding this distinction, choosing the correct ByteArray methods, write unsigned byte, read unsigned byte, and consistently handling data as either signed or unsigned, you can avoid this error and write robust code that correctly manipulates byte data. Remember to always be mindful of the intended meaning of your byte values and choose your methods accordingly.